Hey guys, and today we're going to explore chemical kinetic reactions. And now this chemical kinetics reaction is going to be a simple demonstration / lab to show how you can determine the rate order of specific reactants in a reaction. Now the two things that are going to be reacted today are going to be sodium thiosulfate and hydrochloric acid. Now, sodium thiosulfate has medicinal uses. It can be used to treat cyanide poisoning and has some other interesting things that it can be used for. We have diluted it to a molar concentration of 0.15 using this round bottom flask, if you will. So now we have this 0.15 concentration of the sodium thiosulfate, and we also have our hydrochloric acid, which is 2 molar. Now, 2 molar is enough that you want to wear gloves and exercise caution because it has a little bit more bite than the typical hydrochloric acid that might be found in your stomach that's responsible for breaking down foods. So, in this reaction, we're going to take a known amount and concentration of our hydrochloric acid, and I've already measured out 10 milliliters, and I'm going to place that in each of these small beakers. Now in the beakers, before actually adding the solvent, I went ahead and marked them with a Sharpie at the bottom. And in this reaction, what we're going to be looking for is the presence of precipitation formation, which in this case would be a solid sulfur component, which is a colloid. Now, if you really want to expand your exploration of this lab, you can actually measure the Tyndall effect, something we've discussed before, where it's basically the turbidity or the cloudiness of a solution. But since we're focusing solely on the chemical kinetics, we're going to measure the change in concentration of this sodium disulfate as a function of time. So here's what we've done. I went ahead and took the various volumes of my sodium disulfate, and I have 5 milliliters, 10 milliliters, and I have 15 milliliters. Notice I have 3 graduated cylinders and 4 beakers. Well, I use 4 beakers because I like to incorporate a control whenever I'm doing this investigation. This means that one of the beakers will not receive any of these substances around. Just for continuity's sake, I'm going to put 5 here, I'm going to put 10 here, and I'm going to put 15. Now, when you're doing this experiment, you want to time it. So you may not want to do all of them at once. And so when you're measuring the experiment, you measure it from the addition of the sodium sulfate to the hydrochloric acid to when it actually becomes cloudy and opaque to the point where you cannot see the black mark on the bottom of the beaker, which, sorry, I made a mess. That being the case, we'll switch that guy, make that our control. I make lemons out of lemonade. All right, there we go. So this is our new control. This has a little bit less hydrochloric acid, but because nothing's being added to it, it won't have any type of result, but we're going to use that as our comparison to the other ones. So now I'm going to add 5 milliliters of the sodium sulfate here, and from starting, which me adding it now, I'm going to time the amount of time it takes for a reaction to occur and it become cloudy to the point where I can't see that. Now, you would want to have your stopwatch, but because it's the technology age, it's likely that you've used your phone application and you're clocking the reaction, the time it takes for the guys to interact with one another. Now, for the sake of time, if it's a group experiment, you can actually have more than one person timing it. And so typically what I would do is I'd probably have, a few people in a group, and then we just go ahead and add all the other ones and give them time to react. Now, if you aren't noticing, this first one is already beginning the process of reacting. You can tell that it's reacting because it's becoming cloudy, it's becoming opaque. And that's just a reaction of the sulfur ions forming that solid that's cloudy in water. It's also going to form a sulfur dioxide byproduct as well. And so we've noticed the other two have become cloudy as well. Now, because this is all about chemical kinetics, you're going to stop this one and stop the other ones as soon as it becomes cloudy to the point where you can't see the bottom X. So it's hard to see when it's tilted, but hopefully you can kind of see that it's cloudy enough that you can't see anything's going on. And then what you're going to do then is you're going to measure, now that you've gone ahead and recorded your time, you're going to take the known concentration, say there's no reaction, that's your standard. You'll then record at this concentration the amount of time it took before it became cloudy, and the same with this one, and the same with that one, and then you'll graph them as a function of time. And so hopefully you will be able to determine if it's first order by saying, okay, how does time compare to the concentration? Does it form a linear line when it's 1 over the concentration? Does it form a linear line when it's the natural log of the concentration versus time? Or does it form a linear line when it's perhaps 1 over the concentration versus time? So that completes this lab and demonstration, and good luck if you try doing this investigation yourself.